Hi, everybody, and welcome back to Chee-Tash. My name is Chris, and today we are starting out a brand new book series, mostly tailored towards software developers. We're going to be taking a look at the book Clean Code, which is a book that my company sent me and that I have had for a while now. And I think it would be invaluable for all the software developers out there, especially the subscribers who are wanting me to do more coding related videos. So this might not be as nuts and boltsy, like where we actually write code. I think we definitely will, and there's going to be lots of examples of it in the book, but a way to write code, a philosophy on how to write code. And I think this book would be good for me as well. I've had it for a while. I actually have not started it yet, even though I've had it for maybe close to a year. And I figured, why not? Let's start with it right now. So, Clean Code by Robert C. Martin. We're going to start with Chapter 1, titled Clean Code. And this chapter just kind of lays out what the book is going to be about. Brief introduction, what you're going to get out of this book. And basically what you're going to get out of this book is a philosophy, a way of doing your work. I was going to say a way of life, and in a way it is kind of a way of life. But the author, Robert Martin, he starts out and he says that we'll never get rid of code. And it's funny because I just signed up for a ChatGPT account and I've been using it a little bit for some personal use and also a little bit to help with some work-related things as well. Super great resource. But even amongst all these things that I'm thinking about, ChatGPT, low-code tools, and using ChatGPT to generate your own code for you. Even amongst all these things that seemingly are going to come take our jobs, which we could talk about that someday because, who knows what's going to happen. Businesses still need to be able to generate code based on requirements because the code represents the details of the requirements. So you have some sort of project management tool, like at work we use Jira, and you have stories that represent a requirement that the business has dictated. It's kind of the best way that I can describe it. The thing, though, is businesses need to be able to dictate those requirements into code. If you're asking somebody on the business side to say, okay, let's ask ChatGPT to just build this whole app out for us, which, okay, maybe it can do, and there's examples of it out there, but you need to be able to ask like the specific questions and statements in order to have that happen, which is tough. Secondly, it's still going to involve code, and it's going to involve maintaining that code, cleaning up that code, because yes, maybe ChatGPT can generate the code for you, but how well is it going to be at maintaining the code, refactoring it, going back and stuff? Because probably make some mistakes, probably won't name things correctly. So Robert says that we'll never get rid of code. Code is going to be here. Code is always going to be here. The machines will still need to be able to execute the code, and it will need to be written in a certain format, detail, pattern. The code is not going to be eliminated. The machines need the code, but we need to be able to write the code in a certain fashion that makes it readable for the machine, so when it compiles and runs, it's able to do so in a normal fashion. But also, we need to be able to write it in a certain way for us, so when we go back, make changes, clean things up, that we're better able to understand the code and not have to just spend most of our time understanding what's going on and what's happening. Oops, I'm sorry. Machines doing what we want rather than what we say. And I guess this is an important distinction with, you can kind of have your own idea of what your code is going to do. Like, okay, I'm going to have this cool button at the end of the page that on submit submits this form. Pretty standard stuff. And that's what we say we want it to do, but the machine's going to do rather, that's what we want the machine to do, but it's going to do what we say in the code. So if our code is messed up, it's going to follow that. It doesn't matter how much you want it to do something, right? So there's good code and there's bad code. There's good ones and there's bad ones. There's good teams and there's bad teams. There's a lot of teams in the middle. But there's bad code. Wading through bad code. Robert talks about this in the time that you spend just going through your code and trying to understand what it's trying to do. And this ends up just taking up a lot of time in order to do this. So Robert tries to ask this question, why is the bad code written in the first place? What is actually happening? And a lot of times, and I agree with some of these examples that he uses, is that a lot of times I feel like we're in a rush. I feel like I'm in a rush sometimes. I just got to get this out there because, in Jira, when you point the stories in Jira that, again, represent a business requirement, you're pointing it based on how long it's going to take you to complete that piece of work. And hey, maybe now it's coming up to the point maximum and you're in a rush now. You don't have time to do a good job. You just want things to be done. I feel like that all the time. Like, gosh, I've worked on this story for so long. We just got to get it out there, and we always say that we're going to come back. We always say we're going to come back to the code, but do we ever come back to the code, guys? Mostly not a lot. I can say this too for myself. I say it all the time. Oh, you know what? We'll get this in the next story. Like, I'll come back after we get this story approved. We get it merged into the master branch and deployed. We'll come back. We'll do it. But later, this is this guy LeBlanc that Robert references in the book. Later equals never, which I think is a pretty accurate statement. So, what happens when the later becomes a never? Oops. What happens when the later becomes a never? Well, over time, the mess of your bad code just ends up getting bigger and bigger and messier and messier. Excuse me for once. As I take a swig of my green tea. Over time, the mess gets bigger. Productivity actually ends up decreasing as the mess builds because what ends up happening is that more team members are then allocated to the effort of cleaning up the mess or just even understanding what the mess is all about. So now you're taking team members from other areas potentially for this one area where you're probably maybe not even building anything. You're just trying to untangle the wires. You're just trying to clean up the mess. But you're taking people away from other areas that are important as well. So in the end, and Robert has a nice little chart. Maybe I should have put a picture of it, but it's just a downward sloping line from left to right. And it's productivity on the y-axis and then time on the x-axis. And over time, the productivity goes down on one of these projects as the more team members you're recruited for it. And overall, it's not a very good scene. This is not what you want, to just push more people towards something to untangle the mess. It ends up driving your productivity down. And I'm trying to think. See, they don't know the difference between a change that matches the design intent change. Furthermore, they and everyone else on the team are under horrific pressure to increase productivity, so they all make more and more messes, driving the productivity ever further down to zero. Oh, I got you. Okay. As the mess builds, the productivity of the team continues to decrease, asymptotically approaching zero. As the productivity decreases, management does the only thing they can. They shove more people on the project. So, okay, so the recruitment effort to untangle the mess happens after you start to realize, oh my gosh, productivity has gone down because we've spent so much time trying to untangle this mess. And I'm sure productivity decreases even more once the team members are on that project because, again, you're taking them away from other things. Oh gosh, how many bullet points? Oh, there we go. The grand redesign in the sky. So, you have this project and the code's a mess. So what ends up happening is a rebellion takes place. And certain members on your team start to say, okay, we need to redesign this app. It's too much of a mess. We don't understand what's going on. So we're going to have this Tiger team. And the Tiger team is basically responsible for rebuilding the project from scratch. Rebuilding it from scratch. And everybody now wants to be a part of the Tiger team because, you're working from a blank slate, a tabula rasa. And you can do anything you want. And there is no messy code. So you can have the clear mindset to just build everything clean now. And everybody wants to be a part of the Tiger team because it's a pie in the sky, the grand redesign in the sky sort of attitude. But that rebuild could end up taking a long time. And it's hard. You've got to cross-check references, with the old project and the functionality. You still have to use the old project. So you still kind of do have to understand what the business requirements were in the first place, which are in the old code, but you're just going to try to redesign it, clean it up in the redesign. And that could just take a long time. And what ends up happening is Robert kind of outlines is that this could just prolong the process. This could actually, the cycle of messy code could end up eventually repeating itself because the members who built the project, maybe they move on. Maybe a lot of times they aren't on the team anymore, and you're left with people trying to figure out their code, especially maybe if the redesign ended up being just kind of a duplication of the previous project in that, hey, we had this pie in the sky mentality of, we're going to start from scratch. We're going to write this clean code. And then you end up just writing the same messy code. And then the cycle repeats itself. So kind of a scary situation to be in. But as Robert says here, it's all about attitude. What is your attitude towards the bad code, the not so clean code? And Robert says that we as developers need to start taking more of a responsibility for the planning and the implementing of code because we have our hands so deep in that cookie jar. We know the intricacies and the functionalities and what the code is trying to say, and we should be able to communicate to upper management when things don't make sense or things are not going to work how they think they're going to work. So they want to implement some fancy new feature, but it's our responsibility to maybe say, I don't know if we can get that done in that timeline. We're going to have to make some slight differences and changes to your plan. And it's the same thing with clean code and not so clean code. When you're trying to pump out features in a timely fashion and you often make those shortcuts, well, maybe it's not a good idea to make those shortcuts and just tell your managers the truth, like, hey, I'm trying my best here to write this clean code, but it's kind of taking a while. And I think most managers worth their salt would kind of understand that a little bit. And most managers are going to try to balance out clean coding practices with the required schedule. I had this happen. We had a deadline we had to reach for a certain epic in Jira, which is like an overarching umbrella of a feature, like a page that we were trying to get out. And we kind of sacrificed a little bit because we were on a time crunch and we didn't write unit or integration tests for this. Very not the right thing to do, but hey, we decided, hey, we have a deadline to hit and let's just do it like this. But we are going to be going back and putting in those unit and integration tests. I know we have some, actually a story out there to do that. But that's what the manager is going to do. They're going to try to balance out, okay, we still got to write clean code, but we got to follow the schedule a little bit. But ultimately, there is a balance between those two. And Robert has this analogy here, which is kind of good. If you were a doctor, what if a patient asked you to speed things up by not washing your hands? In the grand scheme of things, okay, yeah, does it save a little bit of time? Okay, sure. But in the grand scheme of things, are you better off if your doctor washes your hands? Yeah. Same thing with coding. Are you better off just writing the clean code even though it might take a little longer? Probably. But does it seem like, oh, this will just be so much faster if we don't do it? Okay, yeah. It might seem like that, but is it the best thing to do overall? Probably not. So this is the Primal Conundrum. Developers don't want messes, but they also feel pressure to make messes sometimes in order to meet deadlines. So I have this issue all the time where I do feel like at work, I sometimes feel pressure to just get things out, just churn it out. Hey, it's working, it's compiling, it's running here. I tested it, but did I make some shortcuts? Yeah, sure, I did. So this is the conundrum. How much time do you want to spend on something versus when is it actually due? And there is a balance between those two. So the art of clean code. What is clean code? I guess we're going to get to that on the next slide, but how do you write clean code? First, you have to define it, says Robert. First, you have to define it. And the next subsequent sections of this book, he goes through some prominent computer scientists, software developers, authors, and he kind of gives their definitions of clean code. Because he says, if you want to write clean code, first you have to define it. So there's one author, one guy. Gosh, what was his name? I think it was Bjarne Stroustrup. Or maybe not. No, okay. This will be on the next slide. But Robert says it's sort of clean code is like having code sense. You see options and variations from the code. This is like your spider sense is tingling. And you make transformations in your code base based on just the look and feel of it. Hey, does this name make sense? Hey, does this abstraction make sense here? That's the code sense that you're trying to build by maybe reading this book, is to, when you look at some code, you start to understand and you start to see your context clues and say, oh yeah, okay, we can definitely change this here. Can definitely change this here. So what is clean code? And a lot of people have some different definitions of it. This first guy that I had mentioned, Bjarne Stroustrup, he is saying that code is elegant, code is pleasing, clean code is efficient, whereas bad code ends up tempting more bad code in the way that there's this broken windows theory, which says that, hey, if you go through a neighborhood and there's lots of broken windows, it's going to lead to more broken windows because people think, oh yeah, you can just do that here. Whereas you go through a neighborhood and it's maybe a lot nicer, there's no broken windows, everything's tip-top shape, you're going to be less apt to not take care of things or let bad things happen. So this is this guy's definition of clean code. Exhibiting attention to detail, so you're not having these things, memory leaks, error handling is on point. You're not having race conditions. I'm not exactly sure what that means, actually. I almost was thinking like an infinite loops and stuff, or you have inconsistent naming. So the word that is highlighted here in the book is elegant. Clean code is elegant. And then there's another guy, I think the next guy, Grady Booch, who says that clean code is readable. And it should read like a well-written prose, not like you're reading Lord of the Rings or 1984, which I did for the channel. Just to plug more of the videos. But it should read like it makes sense. It's very matter-of-fact and it's crisp. And it makes it easy for other people to enhance it. Code that is easy to read is also code that is easy to change, because you spend less time trying to understand what the code is actually going to be doing. Makes it so that when you go to make changes to it and add features, add things to the code, you're better able to do that. So it's readable. It's very literate. It's readable by us, not just those machines. And then continuing forward, I think this is the next guy, Big Dave. Or no, was it Big Dave or Michael Feathers, I think was the guy who was had these main bullet points. It's written by somebody who cares, which makes sense. And this is sometimes I think gets lost at work for me, where I'm just trying to do the job in the fastest time possible, the best job that I can. But I think as developers, I think I got to start thinking myself as a craftsman. You have a very unique skill set. And when you have that unique skill set, you tend to maybe care very much about your work, about your craft. So clean code is written by somebody who cares a lot. There's not a lot of duplication in the code. If there is, then you know that you can refactor certain things to reuse certain pieces of code in other places. Clean code, oftentimes, it has one job, which I think this is maybe a bullet point to the single responsibility principle, which I think is going to be covered later on in the book. It's very expressive. Tiny abstractions. Abstractions probably meaning like abstract classes and the use of those in order to have high reusability, I believe is what Robert, or rather Michael, who the author that he's referencing, means there. But ultimately, each line of code that you read ends up being what you expected. There are no surprises, and the language that was written makes it look like it was made for the problem that's trying to be solved. And it's the programmer's job to make the language seem simple and appear simple. But I really like this bullet point here that each line of code ends up being what you expected. So, okay, I think this piece of code here is taking this object and adding it to the database. It's what I expect, and it does exactly that. But maybe oftentimes in messy code, you think it's doing one thing, and it does something completely different, and it surprises you, which is ultimately not a good thing in this situation. But next, Robert kind of highlights here, is this book the end-all, be-all? Probably not. And he's kind of quick to say that as you read this book, you might disagree with some of the things that are said in this book. But it's their school of thought, in that there are martial arts that are different schools of thought. Like in the UFC or mixed martial arts, you have some people maybe that really specialize in jiu-jitsu who think that, hey, that's the best martial art for MMA. Or you have people who specialize in Taekwondo. They think that's the best avenue to go about if you want to be an MMA fighter, or Muay Thai, or Jeet Kune Do, Kung Fu, etc. And Robert says none of the schools is absolutely right. They all bring something different to the table, but within the schools, they act as though their teachings are right. And that's what this book is going to have the same mentality of. Is the book absolutely right? And are there going to be some things that maybe change? I don't know when this book was written, but are there going to be things that change in regards to clean code, especially with the advent of AI, things like ChatGPT? Sure. But within the book, you have to treat everything as this is the way that we do things. You have to kind of have a little bit of buy-in and understand that there are maybe limitations, but we're going to see this book. We're going to see the teaching is in this book as, hey, this is the right way to do things. But do not think, like I said there, do not think we're the end all, be all. And think about, like I said earlier, and sometimes I have to kind of think of my career as a craftsman, as you have a trade. And you have people who are very proud of their trade. And it's almost to have the same mentality here in this job as a software developer. Think of yourself as an author, and you're writing for readers who are going to judge your effort, who are going to need to be able to understand what you do. And they're going to need to be able to use the code that you write in order to someday write new code. And it's going to help a whole lot more if they understand your code on the first go around. And how do you do that? By writing some clean code and by making things easier to read, because it makes things easier to write. So Robert highlights this principle, the Boy Scout rule, which is essentially, you leave the campground cleaner than when you found it. And he says the same thing within a code base. You leave the code base better after you work on it than when you found it. So it's not enough just to write clean code. You got to maintain the code over time. Maintain your campsite. Make it a better place for the next person who's going to come and camp there. So how do you do that? Well, just make one positive change when we check our code. Just make one small adjustment and just try to focus on that. If I can just find one thing, the book, man, it's funny how that often comes up. How that book often comes up in many other books that I reference. But you just make one change and you just focus on that. Hey, if I can just make one small, tiny little improvement in the code to make it a little bit cleaner, every time I go to work on something new and check in the code, hey, leave it in a better situation than when I found it. So this is kind of funny. I kind of put this in here, and it's a quote from Morpheus from The Matrix where he says, Neo, I can only show you the door, but you're the one who has to walk through it. When he's fighting him in the first fight that Neo does, they download martial arts into his brain. So I think of it as the same thing in this book. When reading this book, the book is only going to show you the door, but you are the one that has to walk through it. You're the one that actually has to put these things into practice. And that's ultimately what it takes. Practice. Guys, thank you very much. That's going to do it for Chapter 1. We'll be back next time talking about Chapter 2, and Chapter 2 is titled Meaningful Names. So looking forward to that. Looking forward to all the people who like the coding videos that I do, and I hope this book is a tool to help all the aspiring and current software developers, including me, out there just to be better at our jobs. So thank you guys very much. My name is Chris. This has been Chee-Tash. Take care, everybody.